Air is flowing around the ball from the front to the back. The ball spins in the same direction as the airflow on the top of the ball, but in the opposite direction at the bottom. Because of friction between the air and the ball surface, air is dragged around the top of the ball downwards towards the back. But at the bottom of the ball, air current will flow in opposite directions. The air at the bottom is slowed down by the opposition of airflow created by the ball and oncoming air. The net result of this reaction is that air is deflected downward. Due to Newton's third law, the air exerts an equal and opposite force on the ball, which causes the ball to curve upwards. This Magnus Force becomes very useful in the sport of tennis. In tennis, there are several different shots that utilize the Magnus Force to trick the opponent as to where the ball is going to go, the first being the drop shot. In the drop shot, the ball bounces low and near the net, making it difficult for the player to get to the ball on time. By placing topspin on the ball, the air passing over the top of the ball has a lower velocity and a higher pressure than the air on the bottom of the ball. This change in pressure creates a downward force on the ball, causing it to suddenly drop right in front of the net, creating a perfect drop shot. Another shot where the Magnus Force comes into play is the serve. There are several different types of serves, and one of the more effective serves is the slice serve. In the slice serve, a spin is added to the ball during the serve, causing it to curve in the opposite direction in which it is hit, confusing the opponent. The ball is aimed towards the outside of the court. However, due to a spin on the ball that is placed diagonal to the court, the ball is pulled down and back towards the center line. It is not only the Magnus Force that influences the ball's velocity in air. The fuzz creates more drag on the ball, allowing the tennis player to have more control over the ball. The fuzz also helps the tennis ball last longer, and it resists straining. The drag force on tennis balls is much higher than on other kinds of sports balls. Smooth balls, such as ping pong balls, produce large air wake, like that of a motorboat. The ball's large air wake creates drag and slows the ball down. If you add roughness, the air around the boundary layer of the ball becomes turbulent, which helps to produce a smaller air wake that creates less air drag, allowing the ball to go further. Therefore, the fuzz on the tennis ball creates turbulence at the boundary layer of the ball, which reduces drag. However, each fuzz filament increases drag because they give the ball a larger surface area. The drag that the fuzz produces is interesting because it changes orientation with increased velocity and wears off as the ball ages. In golf, the Magnus Force is used in a similar way. When hitting a chip shot onto the green, it is often ideal to have the ball stick where it lands and not roll. In order for this to happen, a spin is placed on the ball. A top spin on the ball when it is in the air creates a low airspeed above the ball and a higher airspeed below the ball. This leads to a pressure difference between the two sides of the ball, producing a Magnus Force down. This force pulls the ball directly down to the green. Another instance in golf when the Magnus Force is used is in the initial tee shot. In the tee shot, a backspin is added to the ball, which creates a lift force on the ball, pushing it upwards. This force counteracts the force of gravity, allowing the ball to stay in the air for a longer period of time and travel a farther distance. Although the Magnus Force does help with keeping the golf ball in the air for a longer period of time, there is also another large contributor, which is the shape of the golf ball. Golf balls have dimples because the dimples lower the drag coefficient of the ball. A ball that has dimples will travel farther than a ball that does not have dimples. When hit with the same force, the ball without dimples will travel approximately 50 meters, while the ball with dimples will travel approximately 250 meters. The reason for this phenomena is that the dimples cause the air around the ball to be more turbulent. Turbulence is beneficial because when there is a turbulence around the boundary layer of the ball, the drag coefficient is reduced. The turbulence also creates some adhesion of air to the ball, which also lowers drag. The lower the drag coefficient is, the farther the ball will travel because it has less resistance.
The Magnus Force for soccer can be very useful when attempting a goal. The term "bend it like Beckham" was coined by a movie produced in 2002 with the same name. The skill was named after David Beckham because of his ability to be able to bend the ball mid-air while attempting a free kick or a corner kick. Beckham can thank the Magnus Force for numerous goals he has scored using this maneuver. While the ball is in the air, it spins quickly in one direction. Meanwhile, air is flowing quickly past the ball when it flies through the air. One side of the ball will experience airflow that is in the same direction, and the other side of the ball will experience airflow that is in the opposite direction. This airflow creates surface drag, and since there is more drag on one side than the other, then there is a higher velocity on one side of the ball than the other. The difference in air velocities creates a pressure difference between the two sides of the ball, which moves the ball toward the side with the higher velocity. Bernoulli's principle can explain why the two sides of the ball have unequal pressure. The Bernoulli principle states that as air moves faster and faster along a surface, the air pressure will decrease. The opposite is also true, and that as air moves slower and slower along a surface, the air pressure will increase. When this happens, the ball is sucked to the side with lower pressure, causing the ball's path to curve. The reason for this is because of the tendency of fluids to move from higher pressure to lower pressure in an attempt to create equilibrium. Another force present in the creation of Bend It Like Beckham is the wake deflection force. The wake deflection force causes the unequal pressure. The wake is caused by the spinning ball pulling air along with it, which creates a turbulent flow behind the ball. If the ball was kicked without any spin, the turbulence would be symmetrical and directly behind the ball, and the wake deflection force would have no effect on the ball. However, when the ball is spinning, the air flowing over the ball is pushed to one side of the ball. The air that is not flowing over the ball will try to resist the turbulence, which creates a force on the ball that is in the direction of the bend. The popular black and white soccer ball was designed as so because it's very easy for viewers to see on the field and also on television. Also, the black pentagons help soccer players to curve the ball better by being able to track its movement more easily. The typical soccer ball has 12 pentagons and 20 hexagons. This is because manufacturers determined that this arrangement created the most spherical shape.